Okay, so the sample space. Some people I know have had trouble with the term sample space. All it means is, what are the possibilities? You know, when you roll a die, 1, 2, 3, 4, 5, 6. If you roll 2 die, 1 through 12. That's it. It's just, what are the possibilities? Now, along with my dysfunctional way of drawing threes, braces have always been my downfall. You know, I can do parentheses and brackets, but I've kind of got it down now. So braces, I just kind of have to go slow, but it's, you know, one of those things. That's not even a good one. But that's a brace. So you have parentheses, brackets. You technically are supposed to use braces for these. If you use parentheses, I don't care. But you technically are supposed to use braces. So the factors of 20. That just means what numbers go into 20. So we have numbers like, I just start at the beginning. 1, 2, 3 does not. Okay, 3 goes into 18 and 21. So 4, 5, 10, and 20. And then my challenge of another brace. Ooh, that's a good one. Okay, that's it. That's the sample space. Those are all the numbers that are factors of 20. That's all it is. That's all it's asking. Okay, for B, the queens of a deck of cards. You can do whatever you want to symbolize this, but I'm pretty much like, you know, Queen of Hearts, so QH. All right, so we have our Queen of Hearts. That's, you know, whatever, what HQ, QH. Then you got your Queen of Spades. You got your Queen of Diamonds, and you got your Queen of Clubs. I figured out probably why I have so much trouble with braces, because they're kind of like threes, and I think of threes. Okay, now, here's the challenging one. Okay? The challenging one is the Scrabble tiles for the word funny. Well, we want to write down just the tiles that are there, but not all of them are there, because we have F, we have U, we have N, and we have Y. Puny. The reason we don't write both N's is because one N represents the letter N. We don't need to write both of them. But it is redundant. Okay? We're just writing what letters exist in the sample space. N's already been stated, so we don't state it again. Now, that leads to the second question on all these. Uniform or not uniform? Uniform means you have the same equal amount of chances to pull one thing as any other thing. So, is there a better chance of getting a 1 than a 4 on A? No. There's 1, 2, 1, 1, 1, 5, 1, 4, 1, 2. So that's uniform. Is there a better chance of getting a Queen of Clubs or a Queen of Hearts? No, because there's only one of each type. But on C, since there are 2 N's in the word, now there's only 1 N in the sample space, but since there's 2 N's in the actual word, then it is not uniform because there's a better chance of getting N's than Y's, or U's, or F's. Alright? So that's why it's not uniform. Okay, the dreaded tree. Now, these are a pain to do. I talked about in the notes how you can go vertically or horizontally. I traditionally have always gone left to right, but it actually usually makes it a little easier if you go top down. So first off, you have your meats, chicken or roast beef. So I like to put just labels and then put like C for chicken and M for meats. And then I'm going to branch off the tree, my second level, which is my sides. Now, I can have chicken and mac and cheese. I could have chicken with mashed potatoes, or I could have chicken with rice. I could have the same 3 choices. I don't know why I put an M for roast beef. I guess I was thinking meat. I don't know. Roast beef, right there. Or if you're the Grinch, roast beefs. Okay, so with my roast beefs, I can have mac and cheese, mashed potatoes, or rice. And now I have my third choice, which is vegetables. That's a W, so I don't know what's going on. V, E, G. Okay, we'll just stop there. Now, I could have chicken with mac and cheese and peas. I could have chicken, mac and cheese, and green beans. Now, my second choice is I could have chicken with mashed potatoes, and then I have peas or green beans. If I chose rice with my chicken, then I could get peas or green beans here. Now, you might remember me in the video saying, at this point you actually could stop if you wanted to, because if you think about what's happening here, underneath chicken there's 1, 2, 3, 4, 5, 6 choices. Well, that's under chicken, which means there's going to be 6 choices under roast beef, which is going to give you a total of 12. So I'm fine with you not, unless the question would say on the exam or a test, draw a tree diagram, you don't have to do that. So you could kind of figure out already, stop right there. Of course, if you want to, maybe peas, green beans, peas, green beans, peas, green beans. And you go ahead and do that. Now, the shortcut is that little dash method I talked about in the video. We have 3 different options, right? We have the meat, the sides, the veggies. That's why I put the M. There. Okay? I don't know. I'm just making that up. So I have 3 choices: meat, sides, veggies. So think about it. How many choices of meat do I have? That goes here. And if you want to label this, that's meat, to remind yourself what this means. And then sides. Well, I have 1, 2, 3 choices for my sides, and I have 2 choices for my veggies. Boom, boom. That's called the counting principle, the fundamental counting principle. You take all your choices and multiply. So in class, before when we talk about making a code, and you can have so many letters or numbers, you just put those in there and multiply it. So 2 times 3 times 2 is 12. That's the shortcut way. And since this problem does not say which method I want to see, you can do either one. You don't have to take all that time drawing a tree diagram. If you understand the counting principle, boom. So real quickly, just off a tangent, that was the last unit. Let's say I'm talking about clothes. Okay? And I have pants, you can write this on the back, you don't have to, shirts, and ties. Okay? Let's say I have 4 pairs of pants. And I have 8 shirts, and I have 3 ties. You can make a big old tree diagram. That's really going to be really hard to, when you've got that many branches, 8 branches, that's going to be a pain to draw. But the counting principle says just straight up multiply it. Okay? So 4 times 3 is 12. That's 96. That would give me 96 different outfits if I did not care about whether my colors clash or I had plaid with polka dots or whatever, which obviously I don't. So that would be 96 options. They may not be great options, but there's 96 different outfits from that. And then let's say I added another tie. Then, boom, I've got a new tie for my birthday. Now I would multiply 4 times 4 times 8. And that would give me a new number down here that I'm not doing in my head right now. All right, back to this. Same kind of problem. Determine how many license plates can be made if there are 4 numeric values followed by 3 alphabet symbols. Stop me right there. I think the dash method really makes this easy. So first off, I have 4 numbers. And I, do something like that and put numbers. And then there's alphabet symbols. 1, 2, 3, and I put something like this and go letters. Now, it says the first number cannot be 0. All right. It doesn't say anything about repeats or no repeats, so that means I could have, 1, 1, 1, 1, A. Very boring, but I could have that. That's one of the options. I could have 1, 1, 1, 2, A, B, C. You can see how it goes from there. The only thing is, I cannot have a 0 in this first spot. So that means I only have 1, 2, 3, 4, 5, 6, 7, 8, 9 choices. But for the second slot, I can have any digit, 0 through 9. That's 10. And that's 10. And that's 10. And then, alphabet symbols. Well, there are 26 letters And there's 26 letters, and there's 26 letters. And now all you do is multiply all those numbers, and you get 158,184,000 possibilities or choices. Different plates. That's how many from that. And that's with repetition allowed. Okay? Now, I was going to step over to my little bonus page. Let's say I had the same thing. Let's say there was no zero thing. But I had 4 for numbers, and I had 3 for letters. And I didn't have the zero thing, but I said no number or letter can repeat. Well, in the first slot, I have 10 choices, 0 through 9. Let's say I pick 5. That means I cannot have a 5 anywhere in the other 3 slots. So now my second choice is reduced by 1. Let's say I pick 4. So now I have 5, 4. Well, now instead of having 9 numbers to choose from, I only have 8, and then I have 7. That's without, if you can't repeat. And you can't repeat letters, I have 26 letters to choose from, then I have 25. That's not a 5. That's not a marker. And 24. And I would multiply those out. And that would be a smaller, huge number. Okay? So you got to look for those terms with, without replacement, with repetition, without repetition, to say what happens to the numbers. Okay. I forgot to take that part out. So okay, so this wasn't on yours. I forgot to cut this out on my. Oh, I'm just gonna have lines everywhere. Aha. Okay, so your 4 start with range of valid values. Remember, you can have no chance. Talked about this yesterday. I have no chance of winning the Oscar this year, or a Grammy, or a Tony. And if I look outside right now, it is 100% raining. So there's a 100% chance of rain now because it's raining. So your probability always has to be between 0 and 1. Always positive. Can't be a fraction over 1 or under 0. Okay? Or a decimal. Circle the valid probabilities. Well, 3 out of 7. Yeah. 3 is less than 7. We're good to go. The negative shuts that down. Okay? Negative 5, 6 shuts that down. 1.25 shut down because we have a number bigger than 1.
Yes, ma'am.
Just a little bonus for the video. And 1, I almost hit pause, but nah, he's not going to say anything. Forgot about the rate. All right, so 0, between 0 and 1. Okay? Likely, not likely, equally likely, certain to happen. That's basically 0 to 1. So let's think about this. So for A, you're picking a marble for a bag of 5 red, 3 blue, and 2. So that's 5, 6, 7, 8, 9, 10. Always like to write the number first off. Okay? That's our denominator if we were doing fractions. And we will be doing that. Now, what's the probability of a red? Well, that's 5 red out of 10, which is 1/2. 1/2 is right down the middle. So you have an equal chance of red or something else. Right down the middle. Yellow, that would be 2 out of 10. Okay? Well, 2 out of 10 is a small amount. It's less than half. So less than half is going this way. Unlikely. Okay? Purple. What's the chance of getting a purple? Well, since there's no purple in the bag, unless you're a wizard, it's going to be 0 out of 10 or just straight up 0, either way. And therefore, impossible. You cannot draw purple out of a bag with red, blue, and yellow. Where did it melt? The red and blue make purple. Where did it go? Not that. Okay, and then red or blue. There you're going to add them together because you're increasing your chances. I just want red or blue. So red or blue, I got 5 red, 3 blue. That's 8 out of 10. Well, again, since this is my halfway point right there, that's my comparison. And even if I didn't have one of those, just always go to halfway. Go to halfway and think, is this more or less? 8 out of 10 is more than 10. I mean, more than 5. So it's likely. Now, if I said, I pick a marble out of the bag, what's my chances of getting a marble? Well, that would be 10 out of 10. I'm guaranteed to get a marble if I pull out a marble. And that would be certain. Given 2 6-sided die. Well, right off the bat, that tells me we have 36 choices. Okay, we talked about this. We had that little grid in the notes with the die. I will be putting a picture of die and cards on the board during the quiz. So it'll be up here projected for all to see. But there are 36 chances. Everything from 1 and 1, 1 and 2, 2 and 1. Because remember, they repeat. Think about 2 different colors. A red 1 and a green 2 is different than a red 2 and a green 1. They both make 3, but it's a different combination. So your smallest number you can get is 2. Your biggest number you can get is 12, and everything in between. There's 36 options. Now, the sum of 6. This would take literally just looking on the chart or thinking about the ways to make 6. 1 and 5, 5 and 1, 2 and 4, 4 and 2, 3 and 3. Okay? 5 out of 36. Well, again, the little cheat is, think about what's half 36. 18. 5 is less than 18, so that's pretty unlikely. Not impossible, it's not 0. The sum of 1. You throw 2 dice, there's no way to get 1. So that's 0, and that's impossible. Unless one of your dog comes by and eats one of your die. Sum of 12. Okay? Well, there's only one way to get that, and that's a 6 and a 6. So that's 1 out of 36. Okay? And that's pretty unlikely. I did circle the wrong one. So that's what I'm going to do is I'm going to move this up here and do that. Because that's, what I meant to do. All right. You're the star tonight. Okay. Sum that is even or odd. Well, you're going to get either an even or odd number. So that is certain. You can say 36 over 36. You can just say 1. That's certain. That's not it. There we go. Given the following table, as soon as I see a table, I want to know the total. And it's 37. That's the first thing you should have done when you saw this table, when you were working on this. Total them up. Know the amount. Again, this is no different than the one we just did, just kind of more practice. So what's probability of vanilla? Well, there's 7 out of 37. That's it. We're done. Strawberry. There's 5. Out of how many? 37 again. Chocolate or moose tracks. In that case, remember, we're adding them. Because I don't care which one. I just want chocolate or moose tracks. So that's 10 plus 15. That's 25 out of 37. And the chances of butter pecan, I don't think I've ever tasted in my life, would be 0. Why? Because it's not in the list. You can put 0 over 37, or you can just put 0. Don't care. Okay, the complement. We talked about this before. In geometry especially, we're used to thinking about the complement as 2 angles that add up to 90. Well, that's not what we're talking about here. In stats, the magic number, remember, we're going between 0 and 1. So the magic number is 1. 1's our total. Okay? So the complement is of an event is all outcomes that are simply not the event. So the complement of getting a 1 when you roll a die would be 2, 3, 4, 5, 6. There's 5 things that are not that. It's just what is not what I have. Okay? So if I say 1 out of 6 is my probability, the complement would be 6 over 6, 1, minus 1 over 6, which is 5, 6. Just all the chances of it not happening. And the way we denote it is this. Probability of A with this little cute little C up there for complement. Again, mathematicians not too creative. The way to think about this is it's 1 minus the probability of A. That's the math behind it. We just subtract, whether it's a decimal or a fraction. Okay, we're going to draw some Venn diagrams here. Given the universal set, okay, this is it. All the numbers between 1 and 14. So all these numbers are going to go in the box eventually. See this view here? In other words, wow, that was cool. See that view here? Basically, all those numbers are going to go in the box. But we got some things to talk about here first. There's a set C inside the box that are multiples of 3. So I'm just going to say set C. I'm going to put a circle, but I don't put the circle first. I don't know how big it's going to be. So I'm going to just draw some numbers there. So I'm going to look at my list. 1 through 14. I'm going to count by 3s. Well, 3, 6, 9. That's a 19. So not sure what happened there. 9, 12. Those are the numbers that are in that little set, that group. Okay? If I said everyone in this room, if you're wearing shorts, go stand by the door. Okay? This classroom is the universal set. You're all in this classroom. But if I take a subset of you, if you're wearing shorts, go over by the door. Those of you wearing black shirts, go over in the corner by the window. Whatever. That's just a subset. That's all I'm doing, making a subset. Now, if 3, 6, 9, 12 are in the circle, I need to put all the rest of the numbers in the circle. So just fill them in. 1, 2, no 3, 4, 5, no 6, 7, 8, 10, 11, 13, 14. Any way you want. Be creative. Have fun with it. Make it your own little circle. Okay? That's it. That's all I'm doing. I'm putting the ones I wanted in a little bag, a little container, and all the other ones around it. Now, what is the actual set? The numbers in the circle? 3, 6, 9, 12. And I put that funky little brace here. And my 12 looks like a 13, so there. Set D. I want numbers greater than 10. That's not too hard. 11, 12, 13, 14. That's not a brace. Sorry, I'm a little bit more scatterbrained than normal. So, I write set D here, and you can also just put a D. You don't have to write the word set, it's understood. And I'm just going to write 11, 12, 13. Now let's make this a little bit different. Put 14 down there. And now, just like before, I'm going to put all the other numbers, 1 through 10, around that. Anywhere you want. Get funky with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's it. Any way you want. Just put them around, inside the box, but around the circle. Now, let's analyze them. And the reason I'm waiting to do them both, because unfortunately, poor planning, they're both 4 out of the group. So it wasn't good planning here. The denominator is going to be 14 every time. In fact, it's the same answer as both. The probability of 3. Well, there's 4 out of 14. And guess what? Unfortunately, 4 out of 14. I wasn't thinking. I should have made it greater than 9 or 11. And then it would have been 3 out of 14 or 5 out of 14. But I didn't pay attention. Now, the complement is all the other choices. So if 4 are in this set, that leaves 10 outside the set. So that's 10 out of 14. And unfortunately, same thing here. 10 out of 14. Not really good practice. Then it says shade set C. So you can do this with your pencil just lightly. I can't talk. Shade, set, seed. That's very hard. No, I didn't mean to do that. That was not what I meant to do. I meant to use the highlighter, and that just painted it. There's a highlighter here. Highlighter. That's what I meant to do. All right? And then, notice on B, it says shade, set, D, middle C, which means don't shade, set, D, shade the complement of it. There you go. Oh, let's have some fun. Ooh, yeah. Pretty. Look. Purple and yellow make red. Good thing you could get a little art class in here, too. All right. Number 9. Let's get back to a pen. We really focused to write with. Okay. What does it mean for two events to be independent, and how can you tell? Okay. It means the outcome of one does not affect the other. Outcome of one does not affect the other. So, pulling a number out of a hat and spinning a spinner, no effect on one another. Pulling a card out and replacing it, the deck's exactly the same way it was the first time. Okay, so that's independent. So, a key word here is going to be replacement. Well, I should say technically with replacement. If you replace, it's independent. Or it could be two separate things, like a spinner and a die or something like that. Oh, number 10. Okay, this just like we did yesterday, just more practice. Remember, when they're independent events, we're just going to straight up multiply. That's all we're doing. So we're going to take A times B. 0.6 times 0.2, and that's 0.12. And we're going to take A times B, 0.21 times 0.72, which is 0.1312. It's a very good year. Now, you've got to be careful, and this will be on the quiz, I promise you, like this. We have here the answer that we just got in the previous two. We have the probability of both. So in this case, we're going to divide 0.234 by the one event to find out the second event. And that's 0.3. And again here, we're going to take the answer, 0.4, and divide it by 0.8 to give us event B. And that's 0.5. All right, number 11. Very easy here. Okay? Determine if they're independent or not. What we just talked about. So you choose a marble from the bag. 1. Then you choose a marble from a separate bag. Do they have any effect on each other? No, they don't. So it's independent. One bag does not affect the other bag. Selecting a card from a deck, keeping it, and when you see keeping it, that means without replacement. Okay, think about it. You're going to have various ways of saying the same thing. Keeping it means without replacement. You're not putting it back in the deck. So the deck is different. The deck is not the same deck anymore. It's changed. That's not independent, which is the same way of saying it's dependent. That's kind of a backwards way of thinking about it, but not independent means dependent. Okay, it's like you all live at home. You're not independent yet, which means you are dependent on your parents for a time being. Okay, like on your taxes, they claim you as dependent. Flipping a coin to get a tail, then spinning a spinner to get a red. Well, unless the coin lands on the spinner and jams it, they're independent. They have no effect on one another at all. Okay, So, we're talking about independent here. If this times this equals that, it's independent. So, if we do 0.55 times 0.20, we get 0.11. So, that is independent. On this one, if we do 0.40 times 0.60, we get 0.24. That's independent. Okay, on this one, the tricky part about this one is we have to think about what's in A. And most of you are going to look and go, oh, hey, 10, 0.10. No. A is 0.10 plus 0.15, so that's 0.25. So you should write that underneath. And B is 0.45 plus 0.15. Remember, this one is overlapping, so it's in both. So that's 0.60. Okay? If you do 0.25 times 0.60, you get 0.15, which makes it independent. On G, though, finally, we're going to have one that's different. 0.25, this is really 0.20 if you need to think about that. That's not going to be 0.27. That's going to be 0.45. Line up your decimals. And this one is going to be 37 cents plus 27 cents, so 0.57. If we multiply those, we don't get 0.20. We get 0.2565, so it's a no. $13. We got 2 red, 4, that makes 6. Okay. What's the probability of selecting 2 purple with replacement? With replacement means nothing changes. So there's 4 out of 6 the first time, there's 4 out of 6 the second time. You just straight multiply it. And that gives you 16 out of 36 if you reduced it as 4 out of 9. And it is independent because they don't affect each other. On B, you have 3, 1, and 7, so that's 11. That's a big 11. There you go, 11. And a deck of cards. Well, the marbles aren't going to affect the cards, so that's independent. So we have 1 green out of 11 times 1, where is it? 4. 1 4 out of 13. If you put 4 out of 52, it's the same thing. Okay? And that's going to give you 1 over 143. Or 4 over 572. C. We got 2 bags. Okay? We got bag 1, there's 3 and 2, so that's 5. And then this one's 6 and 2, so that's 8. Well, on this one, what's probably selecting a green from bag 1 and a red from bag 2? Separate bags, no effect on each other, independent. So there are 2 green, right? Yeah, 2 green out of 5. And there's a red from bag 2. There's 2 red out of 8. Now you could reduce that if you wanted to 1/4. Either way, you're going to get 4 over 40 or 1 over 10. I would accept either answer. And the last one's easy because it says without replacement. Okay? So without replacement, not independent. And we don't have any math to do.